Welcome, guys. Let's wait like 5 more minutes. I'll give the chance more people to join.
Sure.
Nice, 20 participants. Nice.
We're waiting a couple of more minutes, right?
Yeah, 4 more minutes.
Sure.
How's everyone doing? Are you guys enjoying the bootcamp? Good morning, good evening. Well, good morning for me. It's 3:30 a.m. here in the US. Good morning, Abraham. Where are you guys joining from? Shout out to all the internet computer patrons who are joining this lecture at 2 or 3 a.m. I'm one of them.
Right. So I think since we have mentors from all over the world and we have attendees from all over the world, so this is kind of expected, but really happy to see the enthusiasm over here.
Germany. Nigeria in the house. 2 more minutes before getting started with the presentation, guys. Hi, Andrea. Well, let's get started. Welcome to day 4 of the Motoko Bootcamp. With you all, the one and only Saikat is going to be presenting Motoko Mutable states and short time. Go ahead, Saikat.
Perfect. Hey everyone, welcome to this presentation. So I'll just lay down some ground rules. So if you have any questions, please put them in the chat, and Dukakis, who is moderating our discussion, will float them to me, and we'll handle them as we go along. I want ideally this to end up into something like a discussion so that we have an interactive session. Perfect. So if we look at Motoko mutable states, I actually want to start off by looking at the underlying IC a bit so that we understand like what is actually happening under the covers in terms of how canisters interact with state and how we sort of have replicas doing processing so that we can have the nice interface that we get with Motoko for interacting with our state. So we'll talk a bit about how subnet replicas work and how determinism fits into all of this. So if you look at the internet computer itself, it is comprised of things called subnets. So we've already heard this quite a few times. However, what a subnet essentially is are these multiple node machines. So if you look at the screen, all these subnets are comprised of individual node machines, which are performing the same calculation over and over for a particular canister. So essentially, when we deploy a canister to the internet computer, what it does is it deploys that same canister across multiple nodes, and they are basically called replicas. So now, if you look at it from a theoretical perspective, what is happening is every subnet sort of has these 4 layers that it uses to process your canister's messages. So they're the peer-to-peer, the consensus, the message routing, and execution layer. And ideally, what happens is in the peer-to-peer layer, you have all these replicas talking to each other and passing the messages. So I will probably link to some further videos that you can watch after this, which basically goes over how the peer-to-peer messaging happens. So essentially, all the replicas in a particular subnet are sending messages to each other to arrive at the next block. That goes through consensus, which ultimately lets us do message routing between canisters on different subnets or between front ends and canisters. And finally, there is an execution that happens at the topmost layer. So if we look at how that's our state for a particular canister interacts with these subnets, so we can see that essentially we have this WASM block inside a canister and execution. So for every block, the canister has a execution state. Like at every block, the canister state is retained by the replica in this case. And what happens is once a new block is proposed and some messages are passed to the canister, a delta is created based on the processing that happens. So essentially it looks something like this. So your canister receives a few messages, and depending on the method calls that are happening inside it, it creates a delta of the new state. So what is the new state that needs to happen? And if the execution goes through without any traps or without any errors, the new state becomes the current state for your canister when the new block is added to the blockchain. And if it does not go through, essentially your canister keeps your original state. So this is actually the way to think about this is actually a advantage of the IC, because in traditional servers or in traditional stacks, essentially if something fails, your server can fail and your server can stop working. So then again, you need to do a restart and all those things. But in canisters, your canister can never go down per se. If there is an error that happens, it simply retains its old state. It doesn't go to a new state. So this is actually an advantage with IC. And essentially at scale, what happens as on a subnet is there are multiple canisters running on each subnet, and each of them have their own replicated state across the different node machines. So if, let's say if there are 13 node machines part of one subnet, so all the 13 node machines have all of these canisters which are part of the subnet, and they also hold the current state of each of those canisters. And then when new messages reach any one of these canisters, they are sort of aggregated and put into a block, and it goes through the consensus and peer-to-peer that we discussed before. And ultimately, depending on the new block, essentially all those canisters reach a new state. So this is what essentially happens under the covers. So we will look at a little bit of code now from the Motoko side to understand actually how this works. Are there any questions currently, Lokash?
Let me check.
So
No questions. Go ahead.
Perfect. So for the code part of things, we'll currently look at the documentation. So as part of the daily challenges and everything, you would have also been working with the let and war keywords. So basically, when we are declaring state, essentially we have these two keywords which let us declare what kind of variable we want. So in Motoko, you have let and you have var. Let sort of lets you create a variable which can only be assigned to once. So the equal to in Motoko is the assignment operator, and the colon equal to is the reassignment operator. So let only lets you do assignment once, but if you use var can essentially let you do reassignment multiple times. Notice, however, that these are primitive variables. So essentially, this is a string, this is a natural number, so on and so forth. Now, we have some more special assignment operators like plus equal to, hash equal to, and such. These are basically shorthand for writing like this. So basically, instead of doing num2 equal to num2 plus 40, we can directly write it like this. So there's a list of all assignment operators that you can find over here. But ideally, I find it just easier to write num2 equal to num2 plus 40 because it is more expressive and more readable for the next code. Okay. So in terms of the differences of let and var, we can use even let declarations to do what var is achieving. So in this particular example, if we see, we have this var x equal to 0. However, we could also have done something like let y is of type variable array of max instead of just doing that. So I can actually show an example of this on the Motoko playground. So I have the Motoko playground over here, and basically I can write something like this. Which if I deploy now, there is no problem. So there is essentially no errors. I could have done the same thing using a let declaration also. So I can say something like let y, but instead of, I can say a variable array of nat, and I can do like so we have to, if you notice, if I try to directly allocate 0 over here, it is saying it is an immutable array expression. So what we need to do is we need to say var 0. And now essentially this is the same thing. So in this case, if I write a function like reassign to variables, for x, it is much simpler to just say, let's say 10. And this has no problem. It compiles fine. But if I were to reassign to y, I would actually have to write y 0. This essentially does the same thing, but this is a much simpler to understand from a syntactic perspective to use well. So that is what is shown over here. Now, when it comes to arrays or other complex data types, we can actually have much simpler code if we just use var. So in this case, we can see this declaration is an immutable array. So essentially, we are saying we have an array of type nat, and then we are declaring it beforehand. So here, if I just copy this into my example, you will notice I can access these values. So actually, let me put this over here. I can access the values of A and it has no problem. So I can say return A, and over here I'll say async of mat is the return type. So this will work fine. So I can access the values inside it. But if I try to assign to it, basically since this let is a immutable type, it won't let me assign to values over here. There's one more thing that I want to cover before I get into the array based libraries. But again, if Dukakis, if there are any questions, you can float them.
Okay, let me check. Yeah, there's a question. It says, so if a data center is removed from an IC, the canister hosted on the data center will still be accessible?
Maybe I could just read the question. So if a data center is removed from the IC, the canister hosted on the data center will still be accessible. So the way the IC works is every subnet ideally tries to allocate nodes into different locations. So say, for example, if we have a data center in India and if we have one in the US and one in Japan, so ideally when the NNS is allocating nodes for a subnet on the IC, it will try to have nodes. So one of the nodes of a subnet would ideally be in India, one would be in US, one would be in Japan, and so on and so forth. So that you're geolocated across different regions. That way, when a particular, even if the complete data center goes down, you still have, let's say, if there are 9 replicas running, nodes running for a particular subnet. Out of them, if one of them goes down, you still have 8 others in different locations processing your canister. So in that case, your canister won't go down. So that is the kind of redundancy guarantee that the IC provides to you. However, if all your, like if a subnet allocates all the nodes in a particular data center, and if that data center goes down, obviously that can go down. But ideally, that that is what the IC is trying to protect against when it says things like we are even resistant against nuclear attacks, right? So if there is a nuclear attack on a particular country, then other countries which are hosting other data centers, they will still keep the canisters running. Right? Sure. Okay. If there are no further questions on the variables part, I'll proceed. So
Okay, go ahead.
Another example that I wanted to show over here is, so here notice that I will just bring this back here. So notice that over here we have A is declared with let and Y. Let me declare this with var, and let me make this a max, and let me 2, 4, 5, 6. So the main difference between these two right now is, if I try to allocate reassign to A, I will get a error, right? Because it is and again the compiler tells me that this is an immutable assignment target. So I either need to make this var or I need to not do this. So in this case, but if I do like this, if I say y equal to okay, this is a different. If I do this, then the compiler has no problem. However, in a lot of cases, you actually don't want to replace the entire array. So in some of your lessons you would have worked with, you would have seen that instead of like you are having to replace the entire array with a new array to sort of push values in. So we have that, like in particular cases, you're appending and then assigning to a new array. However, if you want to actually change the values inside, so let's say I want to do something like, I want to update the first element to be 2. So currently even this is not allowed because it expects a mutable assignment target. Although I have set it to a var, but this is not allowed. So for this to happen, you actually have to even make the array itself var. And now you can even do this. So essentially, if I say like this, now this will also work. So this is the way you can have the elements inside the array be mutable as well. So the array you're declaring as a mutable target, and then you're also declaring that the elements inside are also of a type var, and only then can you mutate the variables inside. So this is a like this tripped me up the first time I was actually working with mutability inside Motoko. Right. Okay. So now that we understand mutable and immutable and have gone through all the different scenarios, I just want to briefly go over the array module. So if you visit Definity's documentation, and as part of your exercises also, you would have been interacting with the array module. So if I go to documentation, and in the base library, I have this array. So a few handy functions to know from this list. So first is something called fold left. So fold left essentially lets you run any function on an array, and then you can get back a end value. So think of it like a reduce. So if you've ever worked with JavaScript, JavaScript has a reduce function. Fold left is your comparison reduce function. So in this case, fold left will start from the left, and there's also another function called fold right, which will start from the right. In JavaScript, you also have a map function, which Motoko also has. So essentially, this lets you run a function on an array and returns the new array as the output. And the third thing that you would need to know is the filter function. This basically lets you specify a function, and if it is true, that will be included in the part of the new array, and if it is false, that particular element will be discarded. So if you've ever worked with another function, with another language like JavaScript, which has similar functions, these are the corresponding functions in Motoko. There are two more functions that would be helpful for you. So there's something called freeze, and what freeze does is basically it takes a variable array and returns a immutable array. It takes basically the mutable array as an input and returns a immutable array. There's also the opposite called thaw, which lets you do the opposite. So essentially it takes in a immutable array and returns a mutable array. So ideally when you're working with arrays and doing a lot of operations, I usually find that these are some of the functions that are very useful. Again, feel free to go through the documentation and go over all the methods that are specified. So in this particular example, they are using a function called tabulate, and basically what tabulate lets you do is it lets you generate a new array by running this function. So essentially you can specify a function, and then you can pass in the size and the function to run, and that will generate a new array. We covered mutable arrays in our example. This is basically what they look like. If you specify this as well, basically you can mutate the elements inside there. Sure. If there are any questions, I can take them. So I think Abraham asked a question regarding the delta. So delta is nothing but basically, if I just go back to my presentation. So you notice at every stage of block creation. So essentially the way state works in the IC is it also maintains a blockchain so that all the different replicated nodes can process incoming messages and propose blocks. So that is the blockchain part of the IC where incoming messages are processed, and then each of the nodes sort of suggests a new block to be chosen as the next block, and then some consensus happens which leads to the creation of the new block. So essentially what happens is, let's say we have this nth step in the blockchain. So new messages are being queued up for every canister. And there are functions that handle every new message that is being queued for a canister. So once those are processed, all those new states contribute to the delta. So essentially every node on a subnet is processing the same messages, and they are proposing the new delta as the changed state from the original state that was there in the last block. So in my nth block, there was my current state, and then after doing the processing of the messages that are coming in, it is proposing, okay, so after n, if we make these new changes, these are the new changes after processing the incoming messages. And the combination of the two leads to the new state of the subnet. And basically, that delta is just the new changes that are required to be made to my current state to progress to the new state. Okay. So the next thing that I want to look at is how do I share data, and like what types of variables are shareable versus what is not shareable. So we have actors, and we've seen that we define things as public. So if I define this as a public function, I can say over here that I can return a nat. And then when I return, let's say 5, the compiler is happy. It has no problem. Which means that nat over here is a shareable type. Essentially, if another canister or if a user using a agent calls this function on my canister, I would be able to return nat. Now there are certain data types that are not returnable. The way to sort of visualize this is, so ideally you ask the question that if I share this data with another agent, will they be able to mutate that data? If the answer is usually yes, you're not able to share it. That is sort of like a guideline. I'll explain with an example. So let's say I have a type of, let's say, person. And for the type person, let's say I have age. Let's give them a name. Type text. And let's give them a name. So, so now, if I want to return this person, I can specify over here that I want to return a person. Essentially, I can have a return. So when I do this and I deploy this, this is runnable. So basically, if I deploy this, the compiler is happy in this case, and I will also be able to call this from the Candy device. So the Candy device is also an agent calling this canister from an external place. So if I call this, it will return me the name and age. Now the thing is, if I add, let's say, if I make the age as variable, so if I say, this is where, so I will, it says that I am not allowed to return this because this particular type contains a non-shared type. So the guideline over here is, again, mostly the Motoko compiler will catch these things for you, but the way I sort of remember this is, if I am sharing a value, that value should only be changeable by me. If I, let's imagine if this were shareable. So what would happen is I can send this to the front end, but then the front end will make changes to the age. But this particular data is supposed to be internal to me. So essentially, if you were able to change my state, then my canister can progress to further, like do further processing. But by the time it is accessing this value again, this value has been changed by somebody else, which absolutely cannot be allowed. Right? So hence, types that are shareable need to be immutable. So again, if I remove this, and if I remove this, essentially, this is again shareable and the compiler is happy. So here is again something that I've learned from experience, and this is probably like a tip that you can use uh, in your code. So Motoko is a compiler that uses something called structural typing. So structural typing just looks at the structure of the uh, types being passed instead of the name specifically. So let's say if instead of over here name, I said uh, okay, not like this. So basically it is if I say instead of this, it just returns an age of type max, but here I say I am returning something like this. This, the compiler is still happy with this. The reason is because although I'm returning this entire thing, it just expects the age to be present. It doesn't care if I have some other properties inside of it as well. It will just pick up the age. And when I call this, my front end basically is going to just receive the age in this case. So how is this useful? Like I can see some people already thinking like, how can I actually use this? So imagine in your canister code, you have code where let's say you have a list of people, right? And in the list of people, you're storing even some sensitive data. But then you want to access that data from your front end, but you only want certain fields. You want to give them maybe their name and their age, but you don't want to give out their email. So in that case, instead of writing duplicated functions, like instead of doing things like func, like a private function that sort of cuts down the variables. So let's say uh, things to return, and over here instead of doing uh, and then calling this from here, you can directly do something like this and then access the person from your list. That way you don't have to write this redundant function. Although like there's no harm in doing this, but I tend to do this to sort of reduce the amount of boilerplate code. Sure. If there are any questions, I can again take them. Can the owner of the method somehow revoke the let immutable status? I am not sure what you mean by this. I imagine what you're talking about is method. So I can try to give you my understanding. So what I think you're talking about is, let's say I have something like name, text, and then I'm returning name. And essentially, I imagine what you're talking about is, can I change the immutability over here inside the function? Ideally, you cannot, but what you could be doing is, you could create a new variable with a type of var and then assign to it this variable, and then you can do whatever you want with it. Yes. So Jonathan is asking, I input 0 because it indexes to the first option. That's right. So Motoko, like many other languages, starts its indexing at 0. So hence, for us to access individual elements in an array, we will have to start with it 0 as the first index. Yes. So basically, Seb also answered the same thing. But let's say so type contains a var, it is not shared. Function in a different actor. Keep mutable shareable information in a different actor. So Jonathan is basically asking whether we want to separate our state by mutable and immutable in two different files. I would not suggest it. So this actually goes to how you and your team would want to organize your file structure inside your project. Ideally, what I end up doing is I try to keep all my logic and my state co-located. What do I mean by co-located? It means, so if I'm writing an actor, let's say an actor called person information. So I will try to keep all the person related information inside it. Let's say if I go back to my type person, here the person will again have some types inside it. I'm not writing that out. Then I can probably have like a let array or let list of people of type person. And then I can have more functions which work on the, okay, so basically add person, and so on and so forth. Add person, remove person, and such. So ideally, this is how I try to co-locate my logic, where if I have an actor which relates to person, I try to keep all the corresponding types, all the corresponding state, and then all the methods that operate on this state inside one actor. And then you can, like, if you really need to, if your file becomes very long, you can try to sort of put them in other files, but at the same directory structure. But this is ideally how I like to structure my project. Again, it depends on the agreement that you have with your team. You can have other structures as well. Okay. Sure. So moving along, this particular documentation page actually has a very nice example, although it's slightly more complicated. So what this is trying to show you is you can not just share variables or lists or like state, but you can even share methods. So essentially, think of an example where you have two different canisters interacting, and then one canister, when it wants the other canister to do something, the first canister gives it a method and says, hey, when this particular condition happens, you call this method and I will do what needs to be done. So this is basically the publisher subscriber pattern. So this is very common with other languages also. The pattern basically talks about this, where you have a publisher and you have a subscriber. Imagine a bunch of scenarios. Like there could be many scenarios. Say, for example, you have something like a push notification, right? So ideally, with push notifications, the way it happens is you sort of give your client's device ID to a, let's say, a Google or a Apple push notification service, and when you send them some payload saying, hey, send this to everybody, it sort of publishes the notification, and then the subscribers, everybody receives that push notification. Ideally, with the IC, there are two ways you can sort of do publishing and subscribing. So the particular one that we are doing over here, like the pattern that we are doing over here, this is actually I would suggest this is a better pattern, although it is slightly more complicated to implement, where you have a separate publisher and a subscriber, and the publisher gives the subscriber a method saying when something happens, then call this. The other way to do it, which we won't discuss over here, but just know that it exists, is to constantly ping your publisher. Essentially, there would be a publisher actor, and you're constantly pinging the publisher, asking whether a particular situation has happened. And if they say, yes, this has happened, you go and do something. So basically, there are two ways of doing this kind of thing. Okay. So in this particular example, again, this example is available on the examples repository for the Definity examples. So here, if you go to Motoko, there should be a PubSub example. So you can play around with this on your local machine. But I'll just briefly summarize what is happening over here. Essentially, we have two different actors. There's a subscriber actor and there's a publisher actor. The subscriber actor has a method called notify, and the publisher actor will have a array of subscribers. So essentially, it is maintaining a list of everybody that it needs to notify when something happens. So how do you subscribe to this? So essentially, when a subscriber is created, something like its constructor or somewhere, it will say that I need to subscribe to this. So the publisher makes this function public so that a subscriber can just send itself to it, and then it will add it to its list of subscribers. And then when that particular event happens, basically this method gets called so that everybody gets notified. On the subscriber side of things, you have this init method, kind of like how a constructor works, where it calls the publisher.subscribe method. And you see over here, the publisher.subscribe will simply add this particular subscriber to its list of subscribers that it is maintaining. In the notify function, this is just, since this is a simple example, they're just incrementing a count, but you can imagine the notify could be doing anything. The notify could be sending push notifications, or it could be doing calculations, or anything you can think. And then they also have a get function to just get a value of the count from inside the subscriber. Okay. Now the thing is, when this particular function, the notify function, now this particular function is a public function, and essentially inside these, the publisher, it can call this notify function, although this notify function doesn't belong to the publisher, it belongs to the subscriber. But since it doesn't have any, again, think from the perspective of the mutability and immutability, since this does not have anything to do with any mutable variable, you can basically expose this. So hence over here, it can directly be called by the publisher. So over here, what is a better approach was, so instead of, so this is like the subscriber, like the V1 subscriber that we created. However, we can actually improve this. So instead of having an actor with the name specified, so you say that notify is the function that you need to call, you can actually say that, hey, we have a function called callback, but we don't specify the name. We just say that it looks like this. Its structure is of a shared function which takes nothing as input and which returns nothing as input. And then this function, the callback function, can be called anything. It can be called notify, it can be called call, it can be called anything. So the subscriber, in this, as in the evolved example, what we are doing is, we are, instead of having the notify function, what we can have is any function that we want. We can have an increment function, a decrement function, and so on and so forth. And then basically, if you can imagine, you can sort of put conditions in, so that in a particular, at let's say daytime, increment is called, but at night time decrement would be called. And in the subscribe message that I pass to the publisher, I just say that it is of type subscribe message. So here it will just call the callback. So when it calls the callback, it can check whether that is increment or decrement or whatever. But that way, you don't have to specify the name of the particular method. You can specify just the type, and then you can dynamically choose which callback to call. So this is just the word example. Again, feel free to try and play with this code from the example that I showed over here. And if you have any questions, I can. Are there any questions on the things that we've discussed? So I see that it's connected in the same canister. Separate files, yes. Separate files can act within the same canister. The way to do it is, so essentially, like I have this actor, right? You can add another file, let's call it utils. And what you have is something called a module. So in Motoko, the way to namespace things is using this module keyword. So what you can have over here is, you can have a function like increment states in a nut, number, and returns another nut. So you can have something like return number. And now what you can do is, in my main, I can actually import this like utils, util dot utils dot okay. It's just mo doesn't need to specify. Yeah, you don't need to specify the .mo. You just write it like this. So over here, then what I can do is, I can call utils like, let's say, let's utils dot implement, pass it to page. So now that we see, so over here, utils doesn't expose this function. It is a private function. So what I need to do, if I make this public, now I can access it over here. Essentially, this is how you can separate out your code into multiple files, but have them still part of be this one actor. Dukakis, are there any other questions? I think I've covered all of the questions in the chat.
Let me see.
If anybody wants to,
yeah, let me open the the stage for questions. You're done with the presentation, right? Saikat, are you done with the presentation?
I'm done with the presentation. Yes.
Okay, perfect. So
there is a question from Abraham. Does that mean we cannot have different actors in one project? No, you can have different actors, but you need to basically it will be different canisters, and you need to define all the canisters in the dfx.json file. That's exactly what you are doing if you are following the video for the daily challenges. You have the actor day 1, the actor day 2, and so on.
So I think that's a very valid question. So how do you have multiple canisters or multiple actors in a single project? You basically need to set it up like this. So I'll just share my VS Code instance because I can show that there. Is my screen visible right now?
Yes.
Okay. So let me make sure. If you see in my dfx.json, let's forget all of this. I have specified a canister as backend. Here, what I can do is I can specify another canister called, let's say, backend 2. And over here, instead of pointing this to main Motoko, so let's call this main 1 more. And let's call this, let's create another one. Main 2. So essentially, I have 2 Motoko files, and in my DFX JSON, I'm pointing backend 1 to main 1 Motoko and backend 2 to main 2 Motoko. So now, let's say I have a function called public func element, which takes a n as a nat and returns a nat. Yes. So this is one actor, and in the other actor, I will just say, let's say, print the nat. So here I don't take anything in. I will make it a public function, and I will make it a message. So now, how do I call this actor 1 from actor 2? So the first thing that I want to do is, I will do dfx start. I will start my replica. We see that it is running. And then I will do dfx deploy. If I do a dfx deploy, I'll see that this project deploys fine. It creates both the canisters as part of the same project. So the next step is, how do I talk between the 2 canisters? So in this example also, you will have seen this. So in the Motoko PubSub example, I'll just change this to a web editor view. In the PubSub example, you'll notice they're importing the other canister directly like this. So basically, we can do an import like this. So I can say backend 1 canister and then specify the name. So it's like this. Over here, I can say, let's say, also import the debug library, debug model from the debug library. I can say debug.print backend 1 dot so I might have to edit this. Let us try to run this and see what we do. Okay, so it says expression of type. Okay, so this increment is returning a nat. So to print it, I need to say debug show. Let us try again. Open a bit. Just put this inside the basket. Okay, so now it should work. So if I actually want to check how, like, what this is doing, I can go to canister IDs. I will open my candid UI. And then paste in my, so main 2 is my backend 2, right? Main 2 is backend 2. So I need to get my backend 2's ID. Paste it over here. So it says print the name. If I call it, I'm using debug print, so I will see it in my replica log over here. So it says 20. So what this is doing is, this particular function is actually calling backend one, and backend one is exposing a public function called increment. I'm passing it an argument of 19. It is awaiting that value. When it receives that value, it is a NAT, so it is converting that into a text, and then debug print prints that into the log of the replica log. So essentially, if you look at the import statement, there are three ways you can actually, there are three kinds of imports that can happen. You can do imports like this. This is basically importing from the from your base library. You can do imports like this, which is doing an import from a canister. And the third kind of import is you can import a local file, which looks like this. Right? But yeah, good question. Somebody is asking which plugin do you use for the syntax. So I have a plugin called Motoko installed. It is by the Definity Foundation. You just need to search for Motoko in the extensions. The first result that returns, the one by Definity Foundation, is the one that you want. Any other questions?
You guys can raise your hand. Let me see. Any other question, guys? No hands raised. Well, I guess we have no more questions.
Perfect. I think then we can close.
Yeah,
if you have any further questions, feel free to ask in the GitHub discussions. Happy to answer over there.
Okay, excellent. Any other thing
I think there was one last comment by Crypto Kaiju. So Motoko does not actually do the prediction of code. It is using something called GitHub Copilot, but that has nothing to do with IC. Basically, I also have a extension called GitHub Copilot. If you are able to get access to it, you can get the code prediction. But this has nothing to do with the IC or Motoko in general. It is for any programming language that you're working. All right, look at this. I think we can close. Thank you, everyone.
Well, guys, that's it for now. We're gonna have more lectures later today. So see you all later today. Enjoy your day. Bye, guys.
Bye-bye, everyone.